All right, are there any questions on 1, 2, and 3? 4, 5, 6, and 7 I have worked right there. 4, it wants to know the average rate of change between 0 and 15. X sub 2 is 15 minus 0, alpha 15, alpha 0. 1 foot per second. So that's 4, 5, 6, and 7. 5 is 3/7 foot per second. 6 is negative 1/6 foot per second. And number 7 is 0. Thank you, brother. Make sure you check your answers and agree with that. You will have a homework check tomorrow. Yes, did I do one wrong?
No, so like if we put a different, like, if we didn't use feet because it didn't have the specific one, would that be wrong?
Did not say feet in the cross?
Oh, it's okay then.
Yeah. You
Okay.
number 10. Oh, yeah, I'm going to get to 10 in just a second. All right, number 8. I did this one real fast. Do y'all agree with the answers? 1, 7, and 4? Okay. That's a pretty simple one. Okay, 9. It talks about a retail store is having a sale on toilet paper. At 2 p.m., the store has sold 15 packs of toilet paper. At 5 p.m., the store discovers that it has sold 57. What is the average rate of change between 2 and 5? Okay, time is always your what value? X, because it's the what variable. And since it's both p.m., you can do 5 minus 2. At 5 o'clock, it sold 57. At 2 o'clock, it sold 15, so you get 14 packs per hour. Number 10, you got the wording wrong on that. I'm sorry. It says Rex is driving from his house to New York. At 10 a.m., he's 200 miles from New York. At 12 p.m., he is 100 miles. It's supposed to be from home, but don't worry about that. That was all worded wrong. I'm sorry about number 10. All right. Sorry about that one. All right. Are there any questions? Yeah, number 10 is you're not going to have one because it's supposed to be from New York. From home, we're just not going to worry about 10, okay? You're not going to have one like that. Yes. Sorry about that. I should have read that closer. How could that be negative? The negative miles per hour? Okay. If you're going to work and the distance from your house to work, 50 miles, where you're going back toward, so in this case, the negative is talking about direction. It's not talking about, because you know in math, negative not only means negative, it means opposite. So in that case, it means you're going back in that opposite direction from where you started.
It's negative velocity.
Yes. Yeah.
So it would be negative 50 miles per hour?
If it had been worded correctly, yes. But like I said, if you don't worry about that. As long as you got 9 right, we're good. All right. Now, guys, what we're going to do. We talked about, what's the name of this function right here? Greatest integer. And it means you round down to the nearest integer unless it's an integer, isn't it? So once again, what would be that first one? Negative 1.5 would be equal to what in this function? Negative 2. Negative 4 would be equal to? Because it is an integer, and 1/3 will go down to what? 0. Very good. And you see how to draw this graph. That will be on your test. You don't have a test on this part B of functions next week. Will be the following week, okay? It's going to be on Wednesday. I didn't want it to be on Thursday or Friday because things get complicated. All right. Next, let's turn to page 45 in your notebook. Today we're going to learn some rules, and you probably are familiar with these rules, and I have ways of remembering some of these things. All right, so talking about the rules, like on this one right here, what's the parent function? What family does that belong to? Absolute value. If you have a number on the outside, that deals with moving it up or down, okay? And if you see it on the outside, it's what you, because you're going to talk about something in a minute that's talking about seeing on the inside. Inside is opposite what you think. Outside is what you think, okay? So if it's a +4, it means you're going to move the function up what? 4 units. If it's -6, you're going to move it Shift it down 6 units. If it's minus 3, I'm going to shift it what? Down 3 units, okay? Shift it down, okay? And you're shifting down the parent function because that's where they originates from what you learned last night. Now, if they're on the inside, that's horizontal. That deals with moving it right or left, okay? Right or left, and it's opposite of what you think. If I see a plus 3, I'm actually moving it what? Left 3. If I see a minus 2, it's actually what? Exactly. Okay, those are the easy ones, like those two. And over here, these are ones you have to think about. But a negative sign, guys, on the outside is a reflection about the x-axis. Right now, just know it's a reflection. I'm going to teach you how to do that in a minute. That's a reflection about the x-axis. And we talked about this earlier about the reflection about the y-axis. In reflection of the y-axis, which coordinate changed? Your x or y? X. So in the reflection about the x, which coordinate changes? The y. Okay, we're going to tie that together so you don't have to memorize something new. But that's basically what happens. Okay. These two are what gives students most trouble, but once we practice it, you should be fine. It's talking about having. Okay. First of all these are plus and minus, wouldn't they? You see, this is multiplication. Multiplication. Okay. If it's on the outside, it affects the y values, okay? You're vertically stretching or shrinking, okay? So if you have a whole number 3 on the outside, you're stretching by a factor of 3 vertically, and that's how you write that, okay? If it's a fraction, you put shrink by a factor of 1/2 vertically, okay? Okay, because on the outside, it's the y. Now, when it's on the inside, it affects the x. And how I remember, these are the two that's hard to remember. If it's close to the x, it affects the x. You got me? Close to the x, it affects the x. So, if it's outside, you're stretching by a factor of 3. If it's a fraction, you shrink. Well, when it goes inside, like I said, inside is opposite of what you think. You would think stretch, wouldn't you? Because it's a whole number. But it's actually going to shrink by a factor of 1/3. Like here, you would shrink by a factor of 1/3 horizontally, because horizontal is the x-axis, isn't it? Here, you would think shrink, wouldn't you? But you're actually what? Stretching by a factor of 3 horizontal. Do you see that? And right now, what we're going to practice is just describing what would happen. We're not going to graph it right now. We're just going to describe, okay? Yes?
If it was like 2/3 inside the absolute value,
I would never give you something like that. In all my years teaching college, I've never seen something like that in textbook. If you had something like that, I would just pick some points and graph it, okay? Instead of trying to do these rules, because that would get a little rough. All right. So on this part right here, we're going to do 1 through 9. And it says identify the parent function. So right now, I want you to just go through each one of them and identify the parent function for me. Just tell me about the name. And then we're going to go back to do the other ones together.
Freshmen N through Z to the auditorium for pictures. Freshmen N through Z to the auditorium, to the auxiliary gym. Thank you.
Y'all remember doing these rules last year? Y'all probably didn't get to those harder ones, or did y'all do those harder ones? Y'all did a little bit of them? Yeah, like y'all just learned the rules. This is the hardest thing to put together so far. That was 6 hours. Every piece is green just about. What is that made of? Legos.
Man, I had like 8 Lego car things when I was a little kid.
This is like the top.
I used to really talk about how
do you have anything stretching by a factor of 1.5? I'm going to buy them all.
All right. Number 1. Okay, what parent function is this? Okay, now we're going to write how we're going to write the description. It's inside the function, a minus. So we're going to shift it what? Right 4 units. That's what you write. Shift right 4 units. Number 2. What type of function is that? Cubic. And this minus 2, is it on the inside or outside? Outside, because if it was on the inside, guys, it would be like that right there, okay? But we don't have that. So that's on the outside, so I'm going to shift it what? Down 2. It's on the outside, so it's exactly what you think. Number 3. What's the parent function? Quadratic. Quadratic, okay? Is it on the inside or outside? So I'm going to shift it what? It's opposite of what you think. Left 4. I hope you're texting Mom and Daddy right now, Jackson Nolan. Okay, that's right. I'm sorry. You got to dig on that. Thank you. All right. You finish that email. Finish that email. Okay. Number 4. That negative's on the outside. What function is that? The square root. What does that negative do on that side? Reflect about the x. Okay, now, on these next ones, when you start seeing more than one thing, you're going to say, okay, Mr. Esther, I'm going to teach you a trick where I had to learn the hard way in college. There is a particular order for which you need to do stuff, just like order operations with expressions. When you're plotting these, you need to work from left to right, okay? Left to right. So just start writing it left to right so that will get you used to it, okay? And not so much on these, but when you start that horizontal stretching and vertical stretching, that's when it really goes into play, okay? So, but let's just write it from left to right. What's the first thing I encounter? We're going to shift it what? Shift left 6, and then down 4 units. Number 6. The 6 is inside the absolute value, correct. It should be this right here, I'm sorry. I need to retype my notes. Alright. So, the 2's on the outside, whole number, multiplication. Am I stretching or shrinking? Stretch by a factor of 2 vertically. Does it affect the y or x here? When it's on the outside. Y, so I'm going to put vertical. Stretch by a factor of 2 vertically, because the y-axis is vertical. If it's on the inside next to x, it affects the x. Stretch by a factor of 2 vertically, and then what does that minus 6 do? Move right 6 units. Okay. Number 7, what type of function is that? Square root. We move from left to right. There's a 1/4 on the outside. Stretch or shrink? Shrink by a factor of what? By a factor of what? 1/4 vertically. It's important that you put vertically. And move what, right or left? Left 3. So we're just going to call these 2 out. Yes, you sure can. That's fine. Number 8. What type of function is that? Square root. I got a 3 on the outside. Am I stretch or shrink that? Stretch by a factor of 3 vertically, and then move what? Move left 8. Very good. Number 9. Oh, what type of function is number 9? Reciprocal. Very good. Is that minus 6 on the inside of that function? So I'm going to move right 6 and then what? Up 8. Okay?
So shift left 6
move right 6, buddy, because it's on the inside. All right. Take a moment to digest that. So our learning target was today, I can describe the transformation functions. Basically, you're just describing. In page 49, that's your homework. What you're not going to do right now is like 12 or 14 questions where you're just doing what you just did. We're not graphing any tonight, but I'm about to start teaching how to graph, okay? I just want you to practice describing the rules tonight, okay? Does everybody understand that? All right. I need a hand signal to tell me from everybody if you understand how to describe the transformation of a function. Lisa? Okay. Are y'all good? Okay. We're just going to do the easy ones today. That's real easy. And then we probably do the hard ones, start them tomorrow, okay? All right, turn to this page. It's in your notebook, page, not 47, I don't like that page, 51. You see I put more note pages in one note because every time before I plan, I just look at the ones I see which ones I want to use. All right. I'm going to tell you, the easiest ones are the ones that don't involve reflection or stretching and shrinking. If it's just moving right and left, these are the easy ones, and you can just do it in your head, okay? So, page 51, honey. All right. So our number one, and we're not doing every one of these because you're intelligent, you don't need 15 examples. So I'm not going to bore you with 15. There's only certain ones. You see the ones I'm highlighting? Okay. So number one, it says graph the parent function and sketch its transformation given. What's my parent function there, guys? Square root. So we know how to sketch that. What numbers will we choose for our parent function? 0, 1, and 4, because they're perfect squares, aren't they? Yeah, you're going to show me the parent function and then the transformation. And any graph you have on your homework or test, you'll be able to see the grid lines clearly, okay? Now, what is the rule here? I'm going to move it what? Right 4. So I'm going to go right 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So move over here somewhere. And I just did my transformation. All right. Number 3. What's my parent function here? Number 3. Quadratic. So let's graph the quadratic. 1 squared is 1. 2 squared is 4. You talking about we're going to study the quartet function? Yes, that's next unit. No, unit 1 is just the basic functions like square and cubic. I know you talked about quartic a little bit last year. We go with depth with quartic next unit. Next unit is all about polynomials. Quadratic, cubic, quartic, quintic, all that. Alright, now this plus 4 is on the inside. So that means shifting it right or left. What will we do in this case? Left. Okay, we're going to move each unit left. 1, 2, 3. Okay, left. Sorry. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Wait.
Yeah, it's
1, 2, 3, 4. Yep. Gotcha. All right. Why don't you do number 5 right now? Like I said, we're not doing all these, so just go with my flow for number 5. Now, if you don't like the graph paper I have on the sheets, you can draw your own graphs on graph paper and do them on your homework, okay, whenever we start doing homework on this. Why don't you do 5 and 7? Just do 5 and 7. That's where we're going to stop today. Go ahead and do 7 after you did 5. And we'll pick up on 8 tomorrow. Bless you.
Last call, all freshmen who have not had their pictures made, please report to auxiliary gym. Any freshman who has not had their pictures made, please report to the auxiliary gym at this time.
Bless you. Check your work number 5. Did you get something that looked like that? Are you allergic to math? Red. That's why I'm so glad, our school colors are red and my chairs just happen to be red.
Okay, well, then I'll do my other.
Thank you. Alright, number 7. Last one for the day. We're going to call it, and we're going to save the hard ones tomorrow so we can marinate those over the weekend and clarify everything on Monday. Number 7. So we got 0 as a cubic. Put something like this. So I'm going to move it what? Left 2, up how many? I'm serious. If you don't like these graphs because you can't see the grid lines, use it on graph paper. Because I'm probably going to start using graph paper tomorrow because I don't like these. I got to see grids. I got to see boxes to be exact. Okay? Are there any questions? Good class today. Homework is just describing. Okay? And guess what? I worked your test, and there's no quadratic formula on the test. They can all be factored tomorrow. Then you're up a creek, we're out of paddle.
So tomorrow,
I'm trying to help you.
tomorrow is just like
12 radical and quadratic equations. But you're going to have about 15 minutes to take because it's either you know it or you don't.
Try to get it.
And then we're going to go over this and just hit these hard tomorrow. It's a regular schedule tomorrow, so we have a regular class period.
radicals are just like the square root, working those out. Yeah, because last year was a home game.